Welcome to the Real-Time Clock RTC chapter of the HT32 MCU Basic Tutorial. This tutorial will introduce to you the HT32 MCU RTC function. We'll introduce this function from four aspects: structure and functional description, registers, library, and example description. The first section is RTC structure and functional description. The real-time clock, RTC, is a peripheral device used for precise timing. It provides time recording and timing wake-up functions for microcontrollers. It includes a 32-bit up counter that enables high-precision counting and reduces the frequency of counter overflow. This enhances the system reliability and stability. The programmable clock prescaler meets a variety of RTC time-based requirements, improving the accuracy and stability of time measurement. The RTC is provided with a high-precision preset time interval value by a 32-bit compare register, enabling it to trigger an alarm or an interrupt more accurately. The RTC supports two clock sources: LSI oscillator clock and LSE oscillator clock. The microcontroller has more flexible wake-up options thanks to three different RTC interrupt or wake-up settings, and the ability to continue running in power-saving mode. Then, we will briefly introduce the RTC structure. The RTC clock source is located at the top left corner. Different sources can be selected by configuring the relevant register. To the right of the clock source is the prescaler, which divides the clock source to a specific frequency. Below this is a 32-bit up counter that counts the clock signal output by the prescaler. Below this is a compare register, which can be set to obtain an accurate preset time interval value. To the right of the counter are the three main status flags of the RTC. From top to bottom, these are the CK second occurrence flag, the counter overflow flag and the compare match condition flag. To the right of these are the RTC interrupt and wake-up output. The APB bus and ISO signal isolation from the power control unit are located at the bottom left corner and are used to connect the RTC to the APB bus. The RTC has three main functions: the timer function, the interrupt and wake-up function, and the RTC pin output function. For the timer function, the RTC generates an accurate time base, such as second and minute, by selecting an appropriate frequency division factor, thereby enabling precise time measurement and recording. For the interrupt and wake-up function, the RTC interrupt or wake-up event can be triggered at a specific time, or periodically by configuring specific registers, thereby waking up the system or executing a specific task. The RTC can operate in the MCU power-saving mode. This makes it commonly used as a wake-up source in the power-saving mode. When a wake-up event is generated, the RTC sequentially wakes up the HSI or HSE oscillator, the PLL circuit, the LDO and the CPU core to restore normal system operation. For the RTC pin output function, the RTC allows events to be output to the external pin by configuring specific registers. Regarding the RTC pin output, the pin output format is primarily determined by the configured mode, polarity, and event. The RTC pin output modes primarily include the pulse mode and the level mode. The events primarily include the compare match event and the second clock event. There are two polarity options: high-level active and low-level active. The main difference between the different polarities lies in whether the pin output is high or low when the output event occurs. A compare match event occurs when the counter value is equal to the value set in the compare register. A second clock event occurs when the falling edge of the second clock arrives. In the pulse mode, when an event occurs, an active pulse signal is output on the output pin. In the level mode, when an event occurs, an active level is output on the output pin until the ROLF bit is cleared by reading the ROLF bit. The second section is about RTC registers. Then, we'll briefly introduce the RTC-related registers. The RTC counter register is used to store the RTC time count value. The RTC compare register is used to store the specific value to be compared with the RTC CNT register. The RTC control register defines various RTC circuitry control bits. The RTC status register stores various RTC flags. The RTC interrupt and wake-up enable register is used to enable or disable various RTC interrupts and wake-up functions. In order for the RTC to operate in the MCU low power mode, the above registers are located at the VBAK backup power domain. The RTC counter register, RTC CNT, is a 32-bit up counter that stores the RTC time count value. The RTC compare register, RTC CMP, is used to store the specific value to be compared with the RTC CNT register. This register can be set to define a preset time interval value, which is then used to trigger an interrupt or wake-up event. The RTC control register, RTCCR, includes various RTC circuitry control bits, including RTC clock source selection, prescaler setting, oscillator enable and so on. The RTC status register, RTCSR, stores various RTC flags, such as counter overflow flag, compare match flag. Reading this register and checking the specific status flag bit can determine whether the corresponding event has occurred. The RTC interrupt and wake-up enable register, RTC IWEN, is used to enable or disable RTC interrupts and wake-up functions. The third section is RTC Library. Holtec provides a standard peripheral firmware library including macros, functions, and examples for peripherals. Using this library does not require users to have advanced knowledge of the HT32 MCU peripheral specifications, thus significantly reducing development costs. The following will introduce several RTC-related functions. The first function is used to select the RTC clock source either from LSI or LSE. The second function is used to select the LSE oscillator startup mode, either normal startup or fast startup. The third function is used to enable or disable the LSE clock. The fourth function is used to enable or disable the RTC compare match function. The fifth function is used to set RTC prescaler. The sixth function is used to get the RTC prescaler setting value. The seventh function is used to enable or disable the RTC timer. The eighth function is used to get the RTC counter value. The ninth function is used to set the RTC compare match value. The 10th function is used to get the RTC compare match value. The 11th function is used to enable or disable the specific wake-up source. The 12th function is used to enable or disable the specific interrupt source. The 13th function is used to get the RTC flag. The 14th function is used to set the RTC output function. The 15th function is used to enable or disable the RTC output. The 16th function is used to get the RTC output level mode flag. The fourth section is RTC Example Description. Finally, we'll provide an application example to summarize this tutorial. This example is one of the standard peripheral firmware library examples. It should be used with the hardware starter kit. During the experiment, you can observe the changes in the LED 1 indicator light on the start kit carefully over time. The program is divided into two parts: the main loop and the interrupt service routine. The example program first determines whether RTC configuration is required after startup. It then enters the main loop to monitor the time update flag, prints the time when it has updated. The interrupt service function monitors the time update interrupt generated by the RTC. It then sets high the time update flag to update the time in the main loop. This approach has the advantage that the interrupt service function does not occupy a significant amount of time, thereby preventing interference with the normal execution of other programs. The actual application of the example. When the example has been programmed into the development board, the RTC clock must be configured using the serial port debugging tool. After this, the time will update continuously in the serial port debugging tool. At the same time, the LED 1 indicator light on the start kit will flash once every second. Here are critical codes of this example. Since the RTC can only be reset by a backup domain power on reset, it is not necessary to configure the RTC every time the system is reset. In this example, a flag bit is written to a specific register in the backup domain to indicate whether the RTC needs to be configured. Therefore, the RTC configuration process in the example is primarily divided into the following 4 steps. 1. Determine whether RTC configuration is required. 2. Initialize and configure the RTC. 3. Configure the initial time for the RTC. 4. Enable the RTC and write a flag bit to a specific register in the backup domain to prevent it from being reconfigured after the next reset. The RCT configuration includes 1. Initialize the RTC registers. 2. Configure and enable the low-speed external oscillator clock. 3. Select the RTC clock source. 4. Set the RTC prescaler parameter and relevant interrupt or event. Holtec has a professional service team to assist in the development, design, and after-sales service. Welcome to contact our business unit for more detailed product information and consulting services.